All right, welcome back. And hopefully last time you saw that these electrons, so electrons like to go in certain places. They have these orbitals that they go in and they are kind of in a space. And there's different types of orbitals. There's different distances from the nucleus they are. And there's also different shapes for the orbitals. So there's the s orbital, p orbital, d orbitals. There's actually an f orbital too. I'm not really going to get into that, but the realization is that electrons have like an address, and so like how you live somewhere, and you probably have an address, like a home address. If you live in a city or a town or something like that, and you can say, well, I live in the United States, or I live in the state of Michigan for myself. And then you live in a town, I live in the town of Ann Arbor, and then I live in this address, and so on. And so it kind of, you have this bigger address, but then every time you get more specific, that's kind of like what electrons have. Electrons have energy levels. They are in some energy level, a 1, 2, 3 energy level, but then they have this shape of orbital, and then they have this position in the orbital. And so what we're going to do today is we're going to look at how to address different parts of the atom with the electrons. And so I'm just going to kind of walk through a couple things, and hopefully this will make some sense. And so if I start with, let's say I have the first element, hydrogen. Hydrogen has one electron, and we saw that there's the nucleus. The nucleus is the center, has positive charge, and as we go further and further away, the electrons are higher energy levels. They're easier to pull off if they're further away. But we also saw that there's some different patterns that we got in terms of how difficult it is to pull off some of these electrons. So if I start with hydrogen, hydrogen's right here, and the first element, so this is hydrogen, and I want to have, it's got one electron. So electrons like to go into the lowest energy level possible to start. They start filling in, and so the lowest energy level is the 1s, energy level 1. Remember, it has one possible orbital, so it's the s orbital, and so it's got one electron. And it turns out electrons actually have something called spin also, and so electrons, they can spin up or they can spin down, but they can't spin the same direction in the same orbital. And so one electron we're going to put as spin up. I usually just draw little arrows, and so when we say that hydrogen has what we call some kind of electron configuration, hydrogen is 1s, and because it has one electron in the 1s orbital, we put a little 1 up here. So we say that it's got a configuration of 1s1, and like not to the first power, it just means it has one electron. Well, that's the first one. If we go on to the next one, helium. Helium's right here, and it's got 2 electrons. And so, well, where's that one going to go? It's only got one place to go, because we don't want to start putting them into these. It's got to fill up the lower ones first. And so helium is going to have a spin up electron and a spin down electron. And we say that this is helium. It's because it's got 2 electrons in this. We're going to call it 1s, and I put a 2 up here. Say 1s2, not squared. It's a 2 because it's got 2 electrons in this. So that's the configuration for that. So now, as we've filled up the 1s orbital, and we're moving on to the second row of the periodic table, we see that there's a huge drop in the energy that it takes to remove that outer electron. And remember, there's a couple factors in this. So a lot of you hopefully remember that as you go down the row of the periodic table, you start going out in energy level. So now we're further away. We're in the second energy level, where the N equals 2 energy level. And as we're further away, it's easier to remove that electron. So now the 1s orbital is filled. We jump now to the 2s orbital, which is a little further away from the nucleus. And so some element like lithium is right here. If I have lithium, that's going to be another electron in the 2s orbital. So it's 2s, like that. Okay. But then I look at the next element, beryllium. Beryllium is right here on the periodic table. Well, that's still, this energy level is not filled yet, and so we're starting to see a pattern here. As we fill in electrons, they want to get filled in by the lowest energy first. Electrons want to be as low energy as possible, and so it's going to get filled in here. Okay, so remember, now we got this spin up, spin down, and so beryllium, if I were to do beryllium, well, for lithium, so lithium, we did that first. That was 3 electrons, and we'd say it's got 1s2 and 2s. It had 1 electron, so it'd be 2s1. Here, beryllium, so beryllium, we've got 1s, and there's 2 in there. Here, we've got already 2 electrons in the 2s, so 2s, but there's 2 of them, so we have 2s2. Okay, lithium would be very similar. Lithium would be 1s2, but 2s would just be 1 because we haven't filled that up yet. So we see that there's an increase in energy, but then as we drop to boron, there's something interesting happens. We start a little dip in the energy. And so the question is, well, why does that happen? So as I look at boron, boron's right here. Well, we've now put a new electron into we started a new energy orbital. Sorry, we started a new suborbital. And so that's the 2p suborbital. And so we're now putting that here. And as we start new orbitals, as we start putting electrons in new places, it's a little easier to remove that now. Okay, so what does that tell us about when this thing is filled? Well, whenever things are harder to remove, it tells me that it's very stable. Remember, helium, super stable. It's got 1s, and the 1s energy level is now filled. The N equals 1 energy level is filled, so it's super stable. It's really hard to remove that outer electron. Beryllium is here. The 2s is now filled, so it is more stable. But then as I start entering things into the 2p orbitals, they become, it's a little easier to remove this because it's not as stable. So the 2p is filled in. What do we see what's happening here? So this is 3 things are going upwards. And so that tells me something about how it's filled in. It's actually, instead of filling in this other orbital, because if that were to happen, then you'd see a little dip down with the carbon as well. But we don't see that. And so we actually see electrons going into this area here. And we have another one going into here, right? And so these get filled in, and that causes this little rise in energy here. So when we're at nitrogen now, this is nitrogen. It has 7 electrons. And if I'm looking here, pen, So nitrogen's right here. We can see we're going up and up and up for filling in these last 3 electrons in the 2p orbitals, and now it's actually become a little bit stable. So once we fill in these 3 things here, they're half filled, it actually gains a little bit of stability. And so nitrogen is right here. And the way we write our configuration for nitrogen, so nitrogen would be 1s, 2, and then we have 2s, also 2. But then now we have 2p, and that is 1, 2, 3. We have 3 here. Okay, so 1s2, 2s2, 2p3 is our configuration for nitrogen. And then if I move to oxygen, which is the very next element, we can see that there's a dip, this tiny little dip right here between nitrogen and oxygen, and how much energy it takes to remove that electron. Well, it's because now we're starting to fill in the rest of these spots in the 2p orbitals. So as we add this in here, add an electron for oxygen. So we're like this now. That electron is a little easier to remove now because it's now starting to fill in these spots, and so that dropped the energy a little bit. But then we're starting to fill in these other ones, and that's going up again. And then eventually we get up to neon, which is up here. So neon is totally filled. And so if I have neon here, fill that in. And then another one here. Okay, so now we're totally filled in, and that's way up here again. Once again, we see that the more filled in things get, it's very stable. I've now filled in the entire n equals 2 energy level. And so this is a really, really stable element, very difficult to remove any outer electrons from neon. It's a noble gas, and so this would be 1s2, 2s2, 2p would be 6 because the electrons are all filled in here. Okay, now as we keep going on down, this continues on down the column. I go into here, we filled in all these here. Now we have 3s, so we can take the next 2 elements, just keep adding in. If I want to do that, I can add these in too here as well. The same filling in pattern. If I'm in the, so hopefully you're starting to recognize patterns here. All these sections here, this here and this one right here, this is what we call the S orbital, so the S block, okay? So the S block. And here, all these here, this is where the p electrons are. So the 2p is here, 3p is here, 4p would be here, and so on. So any outer electrons, they would go here. This is 1s, 2s, 3s, and so on. As we start getting into these elements here, something a little funky kind of happens. So remember, as we are moving down, so if I fill in all these here, 1s, 2s, 2p, 3s, 3p, I'm on the 4s here, so this is 4s, and I start going into here. Remember, this section is 3d because as I get to the 3rd energy level, another set of orbitals opens up. We have the 3d energy level available, and so now this section here is instead of the fourth row, it's now 3d. So I'm going to ask you to try to practice adding in some of these. Write down some electron configurations. We're going to do full electron configurations up to 4s for now. And then maybe in the next time we will look at 3d and some exceptional configurations that can happen in the 3d level.